students, hope you can read this problem. The problem states that a ball is thrown vertically upwards. When it reaches half of the maximum height, its speed is 10 meters per second. Okay. Find the maximum height attained by the ball, and you are supposed to take g as 10 meters per second square. This appeared in NEET 2001. It could appear in any competitive exam. It can appear in exam of first year of engineering mechanics. Okay, so see, if I throw the ball up, I have given certain push to ball, so there is certain initial vertically upward velocity, and the ball, when it is in the air, when it leaves my hand, there it is subjected to only force. That means that's the net force acting downward because of gravitational pull. Okay, so naturally, second law of Newton's second law, F is equal to ma. Net force is mass into acceleration. Net force is downward, which means acceleration is also downward. So the velocity is upward, the ball is moving up, but the direction of acceleration is downward, which means the ball is going to slow down, and so its velocity will keep on decreasing and it will reach a certain height when its velocity becomes 0, and that's the maximum height that the ball attains, and that is what is asked. Okay, after that ball will start coming down. Okay, so consider, so we have already drawn this. Here we have you have ball which is thrown up, and it reaches height of this is the maximum height where velocity has become 0, right? And what you are told is that at half of its height, that means at h by 2, its velocity has become 10 meters per second. Okay, this has become 10 meters per second. Now, how do we solve this? This problem can be solved by two ways. Okay, one is quicker way, and we'll start with that. I will show the another way also. Now consider only this part, right? The ball is moving up with a velocity of 10 meters per second, and now its velocity has become 0, right? So you know the initial velocity, you know final velocity, acceleration is constant, right? And if you are considering upward as positive, right, upward as positive, this will also be positive because velocity is vertical, then g will be minus 10 meters per second square. G is minus 10 meters per second square, right? So here we will consider only movement between these 2 points. Initial velocity is 10, final velocity is 0. You can, and g is given, so you can find the time for travel of displacement of h by 2, right? So what is that time? Time is equal to v minus u by a. Now v is final velocity, which is 0, u is 10, right? It's minus sign here, and acceleration g is minus 10. So this means it is 1 second. So to travel a distance of h by 2, time required is 1 second. Okay. Now see, since the acceleration is constant, right? Acceleration is g. So if you consider these two velocities, initial velocity, let's say v, and this final velocity. So I can say, you can call this is v dash. If I call this v, let's say. So during this acceleration is constant. So you can find out the average velocity, right, by just taking sum of initial and final and divide by 2. So you can find out that average velocity for this travel. Okay. So average, v average, I can say is equal to 10 plus 0 by 2. So 10 plus 0 by 2, which is 5 meters per second, right, which is 5 meter per second. So average velocity is 5 meter per second, time is 1 second, right? So in 1 second, how much distance will be traveled? 5 meters per second into 1, that is 5 meters, right? So h by 2 becomes 5 meters. When h by 2 is 5 meter, total h is 2 into h, right? 2 into 5, that is 10. H by 2 is 5, so h is 2 into 5, that is 10 meters, right? So this is one way of solving the problem where we considered only this portion of the problem, because we are given velocities here and here. But there is another way of solving the problem. Could be slightly longer, but nevertheless I will solve the problem with that method too. Okay. Now what we do is consider these 2 points, this point and this point, and you have a relationship. You can use the relationship v square minus, because you don't have to go to time. No, time is anyway not given. You don't have to find out time. We did find time in first case. Here you don't have to find the time. You know that the relation, another kinematic equation, which is v square minus u square is equal to 2as, right? So we applied this between these 2 points. Okay, so the equation we are applying is v square minus u square is 2as. I am considering these 2 points. So here it is 10 square, because velocity v is 10 here, minus u square, which is unknown. This will be equal to 2. A is minus 10, right? A is minus 10, and s is displacement, which is h by 2. This is h by 2. Okay, so this is your first equation. Now apply the same equation, use same equation, and consider this point and this point. Okay, so here velocity is 0, so I'll write v square, final velocity is 0, initial is u square, 2 into a is minus 10, and now this is the total displacement h. Okay, so we have these 2 equations. Now what you can do is subtract this from this. So that means you will change the signs of this, right? And which means this will get cancelled. This will be 100 is equal to, if you see here, this is 2 gets cancelled here. So it is minus 10h, and this will be minus 20, and this sign is changed, so it is plus 20h, right? So if you do this, 10h, so 100 is equal to 10h, which means h is equal to 10 meters, right? And we had the same answer. Thank you.